This video covers section 3.3 slope. Objective 4, work with applications of slope. Slope, as we know it, is the rise over the run. Whenever you have a rise over a run, this tells you how the y values are changing with respect to the x values changing. Slope can also be interpreted as a rate of change. Slope tells us how fast the y value is changing with respect to x. So if the y value represents the pitch of a roof, the y value would tell you how high a roof goes in respect to how far horizontally it goes. The pitch of a roof tells how steep the roof is. A roof might have a rise of 7 and a run of 10. Other roofs have different pitches. Some are much steeper. Maybe it's a run of 7 and a rise of 10, depending on the style of the home. Sometimes a rate of change is money. How are monies changing per mile? A taxi charges $3.50 per mile. The cost of the taxi will rise by $3.50 for each additional mile driven. Everybody has to take their car to a mechanic at one point in time, and it's the labor cost that's typically expensive. Sometimes it could be the parts, but if the labor charge is $75 per hour, that means your bill will go up by $75 for each extra hour worked on the car. So you hope that part that you buy doesn't take too many hours to install. The one we will investigate further is the grade of a hill. It is stated in percent. A 5% grade would mean that the hill goes up by 5 feet for every 100-foot horizontal change. Remember that 5% is 5 parts out of 100. So that means that for every 100-foot horizontal change, the hill is only going to go up by 5 feet. That tells you how steep this hill is. Example 7, find the grade of this road. We see that the rise is 3 feet for a run of 20 feet. So the slope is 3, which is the rise, over 20, which is the run. The grade is always stated as a percent. And so 3 out of 20, if we write this out of 100, times 5 times 5, that would be 15 out of 100, or 15% grade. You will see these marked on all the hills that are steep, and they're aimed at the truckers that are carrying a lot of weight because they take a long time to slow down. So it's a reminder to them that this is a steep hill. Keep your truck slow. In this example, the following graph shows the cost, which is y, in cents of a nationwide long-distance telephone call from Texas with a certain telephone calling plan, where x is the length of the call in minutes. Find the slope of the line, add the proper units for the rate of change, and then write a sentence explaining the meaning of slope in this application. When we talk about slope, it's always the change in y over the change in x. That helps us attach the proper units to slope. The y values are on the y-axis, and it's the cost of call. In cents. Along the x-axis is the length of the call. In minutes, we have the units attached to slope. It's the cost of the call in cents per the length of the call in minutes. So if we find the slope of this line, we have the point 662 and 234. We'll call this y2 and this y1. So we have 62 minus 34, which is 28. X1 is 6 and X2 is 2. X2, let's keep this consistent. Y2 was on top, so this is X2 and X1. And 6 minus 2 is 4. 28 over 4 is 7, or 7 over 1. We say that the slope is 7, but in terms of rate of change, it says that it's a 7-cent cost for a 1-minute call. Well, that's a fancy way of saying that the call costs 7 cents per minute. This concludes the video for section 3.3, slope. Objective 4, work with applications of slope.